Hello class, this is lesson 4-4 about zero and negative exponents. So we're going to try to look for a pattern starting with 2 to the 4th power. That's 16, 2 cubed is 8, 2 squared is 4, and 2 to the 1st power is 2. So those are all ones that we know already. And if we look at a pattern, every single time I am dividing by 2. So hopefully this will help us figure out what 2 to the 0 power is. If I'm starting with 2 and I divide by 2, it should equal the number 1. And so that's going to be our first rule for today. It seems kind of weird, but any number to the 0 power is just the number 1. Okay? It could be a negative number to the 0 power, a fraction, it doesn't matter. Continuing on with our pattern, if I divide by 2 again, now I get 1/2. If I divide 1/2 divided by 2, I get 1/4. When I divide 1/4 divided by 2, I get 1/8. And then to finish off this pattern, divide by 2 again, I get 1/16. Which if you see, those are all the mirror image of those exponents at the very top. So any number to a negative exponent is going to result in 1 over that number to that positive exponent. Okay? And so these are the two rules that we're going to be using today in our lesson. So why don't we go ahead and do some examples. First, we're instructed to rewrite the problem with just positive exponents. So the first one is easy. I'm going to put 1 over 3 to the positive 5 exponent. There we go. In my next problem, it says m to the 0 power, which I know is just the number 1, so I'm not even going to worry about that. So all I have to change is n to the negative 4th power, so that goes to the bottom, 1 over n to the 4th power. All right, in my next example, the only negative exponent is that x. So that's the only thing that I need to change, which means the 16 and the y are going to stay in the numerator, and that x to the 6th power is going to go down into the denominator. And I'm done. Okay, my next problem says 1,000,000 to the 0 power. Guess what? That is just the number 1. Alrighty, you're done. Look at how easy that was. Okay, my next example, the only negative exponent is attached to the y. So that means the 3 is going to stay in the numerator, and the y that is squared is going to be in the denominator. And that's it. Okay, final example for this one. The only negative exponent is attached to the a. So that means b cubed is going to stay in the numerator, and then a to the 7th power is going to be in the denominator. And I'm done with that example. Okay, let's go ahead and move on now. The next scenario is going to say to rewrite without the fraction bar at all. So I'm going to move everything to the numerator. So first, 1/16 rewritten is 1 over 2 to the 4th power. And now to move that up to the numerator, it's going to become a negative exponent. So it's 2 to the negative 4th power. That's it. All right, my next example, I need to move that c cubed up to the top so that a squared stays there, and then it's going to be multiplied by c to the negative 3rd power. All right. Okay, my next one, 1 over 25 is the same as 1 over 5 squared, and then I need to move that 5 squared to the top, so it's really 5 to the negative 2 power. And I'm done. Okay, my next example has y cubed in the denominator. Let's move it to the top. So that's 2x to the 6th power, y to the negative 3rd power. And my final example in this section, let's change that 1,000 so that it looks like an exponent. So 10 cubed is the same as 1,000, and then I still have that 8. That a to the 8th power, and then I'm going to move that all up to the top. So 10 to the negative 3rd power, a to the negative 8th power. And now I'm done with that problem. Okay, so we're going to move on to our final section now. The instructions say to rewrite using only positive exponents. So any negative exponents, let's get rid of them. So this has 5 to the negative 6. So one way you could solve this is just by adding those exponents together. So 5, and then I have 10. I could do plus negative 6 or just minus 6, which is 5 to the 4th power. Okay, that's the fastest way. I like that one. Another way you could have solved this was keeping that 5 to the 10, but then rewriting 5 to the negative 6 as 1 over 5 to the positive 6. And then I can combine all these together. That would be 5 to the 10th over 5 to the 6th. And then I could simplify those exponents, and it would be 5 to the 4th. So I like the first one, but if you want to try the second one, that's fine. All right, my next example, I need to move that n to the negative 3rd exponent down below. So that 0.8 stays up above, and then down below I have n squared times n cubed. So to combine those n's together, I'm just going to add them. So I have n to the 5th power in the denominator. And now I'm done. Okay, next problem. I have 3 to the negative 7 times 3 to the 11th power. I need to move that 3 to the negative 7 down below, or I could just add those exponents together. So that's what I'm going to do to start, and it's going to be 3 to the 4th power. But again, if you wanted to try the other method, you can start by rewriting it as 1 over 3 to the positive 7 times 3 to the 11th, and then that can all be rewritten as one fraction, and then you can just subtract the numerator minus the denominator. And there's your answer. Okay. All right, final example, 0.5 to the negative 8th, 0.5 to the negative 7th. I'm going to start by just adding those exponents together. So this is going to be 0.5 to the negative 15th power, and then I can move the whole thing down to the denominator, 0.5 to the positive 15th power. And that's it. So that is our lesson for today on negative and zero exponents. Let me know if you need any help in class.